So now we're going to do an example where we're finding linear speed. And some important things come up in this problem that we'll talk about. Okay, a bicycle has wheels 28 inches in diameter. So here's the wheel on the bike, 28 inches for the diameter. A tachometer, I think that's how you say it, determines the wheels are rotating at 180 RPMs, revolutions per minute. Find the speed the bicycle is traveling down the road. So this 180, that's our omega, okay? That's the angular speed. So one of our formulas for linear speed is V equals the radius times the angular speed. Well, we know the angular speed, sort of. We know it's 180 revolutions per minute. Now, we're going to put that in radians. So if we have 180 times one revolution per minute. But one revolution is going to be 2 pi. All right, so our linear speed is going to be the radius. Now the diameter was 28, so the radius is 14, and that's in inches, times omega, which is 360 pi over minutes. Okay, and then we can multiply that out. What's 14 times 360? 5,040 pi, and that's in inches per minute. Now, usually when you think about a bicycle going at a speed, it says find the speed of the bicycle. Usually you want that in miles per hour, right? So I'm going to teach you what I learned. My chemistry teacher taught me this in college, how to change those units, okay? So we'll do the minutes first. If we want to change it to hours, then you're going to make a relationship here. You want to cancel minutes, and you want it to be in hours. Well, there's 60 minutes in 1 hour. So now my minutes cancel, and I have inches per hour, okay? So it's called a unit analysis. So now I need to get rid of the inches. So I'm going to think about, well, how many feet are how many inches are in a foot? So I'll say 1 foot is 12 inches. So then that's going to get my inches to cancel. And now I have feet per hour, so I'm getting closer. I wanted miles per hour. So now I just need to know how many feet. I'll put feet in the bottom because I want it to cancel. And then how many miles, what's that relationship? 1 mile it's 5,280. I'm going to look. I think it's 5,280. Yeah, the 5,280 feet in a mile. Okay, so you might have to look that up. All right, so now my feet cancel. And so I'm left, all my units are canceling except the miles in the numerator and the hours in the denominator. And that, bless my chemistry teacher, but that was one of the most useful things he ever taught me, was how to do a unit analysis. Okay, so now what do I have? A bunch of stuff, right? Well, I'm going to rewrite it for you. So I've got 5,040 pi times 60 times 1 in the numerator, and the denominator I have 12 times 5,280, and this is in miles per hour, which is what I wanted. Okay? All right, so now I just have to put this in my calculator. So let me go clear my calculator. 5,040 pi times 60 divided by, now I'll need to open a parenthesis, 12 times 5,280, and I'm getting, it's about, if I'm rounding to the nearest, it's going to be 15, about 15 miles per hour. Okay. They went 2 decimal places in the book, so they went 14.99. So it's just a matter of how accurate they want it. They really should tell us how accurate they want it. But either way, I'm not too picky. Unless I specify, then I'm picky. So if I say 2 decimal places, round your answer to 2 decimal places, do that. All right. That was linear speed.